In this tutorial, I'm going to show you how to build an HTML5 rotating cube using WebGL. Now, before we begin, quick reminder that every day I host a live stream. It's at 2 p.m. Eastern Time. You're free to join the live chat and post your requests. It could be programming topics or they could be lifestyle topics. That's perfectly fine. And basically you visit ojambo.com, you open up the article, and then you can click on the link to take you right to the live stream. Or if you're already watching a live stream, thanks, keep it up. And if you want to do that, you can simply just scroll down in the article and you'll be able to watch the embedded video. Also, be sure to subscribe, like, follow, and leave comments for more frequent content. Today I'm trying, I tweaked some settings because the GPU fan shell didn't show up yesterday. It's supposed to show up today, hopefully, most likely at night. So I'm hoping to set it up, and then by tomorrow I should be able to go back to using the old phone as a camera, and also to so you won't see this webcam anymore. And I should have an update as well, some testing as well. So one of the tests I've done so far today is I'm using the integrated GPU. I've enabled hardware acceleration, so it should the quality of the video should be better slightly, because I've also upped the bitrate. And as you can see, one of the consequences of that is, if you go back to the article, see when I loaded the page, it said WebGL is not supported. Don't worry about that. I believe that's because Firefox-based browsers, they don't enable it by default. There are tricks you can do. I don't want to bother with that. However, you can use a Chromium-based browser like Google Chrome, Chromium, which I use. So many others based on the Chromium browser, which do have WebGL enabled by default, but you can also go and enable hardware acceleration if you want. That won't bother us for the tutorial. It will work especially on the phones. The phones usually have WebGL enabled by default, so you can use your phone on that. And I said I'll show you also on the phone. We'll get to that in a little while later. Okay, so let's move down here. Where you explain that. So basically what we're going to do is we're going to create a very simple cube, and we're going to rotate it only using HTML5 and WebGL. So that means there's going to be JavaScript, very little CSS, and also even less HTML. So it'll mostly just be JavaScript. We use the canvas if we can, and the WebGL means that it's going to use the graphics, whatever you have, to render the final I guess image, or really just an object. In this case, it's just a cube. It's a glossy like a glass cube. Okay, so what is WebGL? WebGL is a web graphics library. It's a JavaScript API that lets you render 3D graphics inside the web browser using the hardware acceleration, as I mentioned. And like regular 2D canvas, WebGL taps directly into your GPU for smooth and powerful visuals. So the canvas, although it can do 3D, it's not really 3D. It's more of a perspective thing to fool you into thinking that it's 3D. But this time I'm just going to use the GPU's WebGL. There's also something called WebGPU. That one is still experimental. So that's what the feature is going to be. So if you think like WebGL 2.0 is difficult, oh my goodness, WebGPU is even more, it's more hands-on, so you need to be an expert. I actually do like WebGL version 1, because that one had, like, for example, the matrix transformation. It wasn't the best, but it was way better than having to do a whole bunch of math things for something as simple as this one, the cube. So the interactive demo here is not going to work on this particular browser, but I can use a different browser and you'll see it does work. In fact, I'll show you that a short while later. I'll show you how it actually does work. It's a little glare because finally stopped being windy outside. Okay, so you see the rotating cube here. This video, I still haven't changed this video. I'll change this video as well when the tutorial is completed. So for example, just to prove my point, I'm going to open up Chromium browser. Oops, Chromium browser. And I'm going to copy this URL. I'll just show you guys here briefly. So if I open up in Chromium, it should work in Chromium. Yes, you see, it does work in Chromium. You see, you can see it shows up here automatically as well. So you see, there's no problem with Chromium. You're able to use the Chromium browser for this. So what I'll do is, I'm gonna reuse this browser as well. So I'm gonna leave it somewhere. I didn't realize. So that's why I use that browser. Ads are showing up. It's kind of doing a tutorial. Okay, so let's go to the code. So here with the code, you can see we have. Okay, I probably have to close this. It's because I'm using the integrated graphics. So remember, OBS takes up a lot, and especially because I'm actually using the hardware acceleration on a smaller file so I can edit it much faster. But let's go back here. Okay, so the usual stuff, the doc type, then the HTML, and then in the head section we just have the title, and we have some styling here. Just basic styling stuff. For example, the canvas is set to display block 100 VW, that's viewport width, and 100 viewport height. That means it's going to take up whatever your height is. If you flip the screen, or if you resize, like if you're on a desktop, you resize the web browser, it's going to always be 100% width and height. Okay, and then obviously the canvas in the body section, we have the canvas to give an idea of GL canvas, and then we have the scripting. So as I said before, majority of this is going to be on JavaScript. So first thing we do, we get the canvas, and we use document get element by ID canvas. I could also use if I gave it a class, I could have used that. The class, or if because it's the only one on the page, I could also just use query selector. That will work as well. Okay, then we create a GL variable, then that's going to get the context of the canvas, and we check to see if WebGL is not supported. Remember the little pop-up that came up before? It says WebGL is not supported. So if WebGL is not supported, then you can do something else. So this is another way to write better code, in that you don't want people to get upset, because if somebody goes to the page, you're going to expect to see, in our example here today, the rotating cube, and if it's not rotating, they're going to be upset because it's they expected it. So that's why obviously you can write the message, another message, whatever message you want. I just use the alert. Some of you who are new to JavaScript, if you notice here, I didn't put the squiggly brackets. The reason for that is because in programming, it starts with actually C programming. That's where all this newfangled languages actually got inspired from. If you have a statement, like for example, an if statement here, if it's only one line, obviously this is on the same line, but if it's the next line, it will automatically assume that that's the block, that's where it ends. So it will run that, especially if you just have one line. So we don't have to put the squiggly brackets. For example, you see this function here called resize. You see I do have the squiggly brackets because obviously there's more than one line. For example, I get the canvas width, I set it to window inner width, I set the canvas height to the window inner height, and then the GL, remember we have the GL variable up here. Set the viewport is 0, 0, meaning top left, top right, and then the canvas, sorry, on the topmost left, that's 0, 0, x, think of it xy, to the canvas width. So for example, here it would be 0, 0, this would be the width, so it would be here, and then obviously the height, so the height is down here, so obviously that would be down here. So then it would take up that entire rectangle. It's always a rectangle. A rectangle, so meaning a square is also considered a rectangle. So just and then the window. So then we add an event listener, meaning that when the window is resized, we're also going to resize, we're going to run a resize function. So meaning if I go like this a little bit, it will resize it and reset the canvas. That's one of the things I dislike about the canvas element. There's no, it's not responsive by default, even though I put it, for styling, the CSS will work, but that one is kind of going to be scaled and stretched. You're going to actually see it. So you have to use JavaScript. Yeah, they really, when they said it's JavaScript based, they really meant you have to do all this in JavaScript. So this is, I feel this is kind of unnecessary, but it's unfortunate. It is necessary when you try to use the canvas for, as you see for our case. So then we need some shaders. This is one of the things which I said in WebGL version 1, it was much easier, but in WebGL version 2, they expect you to do a lot of this stuff yourself. So this is more low-level stuff. So as you can see here, you need to have a vec3 attributes, and then you have to, this is for the matrix transformation. Remember, we're going to rotate it. So we need the X, Y, and Z, or Z, wherever you are. So we have the model view matrix, projection matrix, and the normal matrix. And we have the normal and the position, vertex normal and vertex position. And then we have this void main. If you might recognize if you done any C programming, remember I said everything is inspired by C. So we get the position, we have a model view matrix, and we multiply it by the vec4. So this is a vector, is kind of a, this is actually from C++. It's like an array. A position, comma 1.0 dot I said XYZ, and then we have the normal, which is mat3 here. And as you can see, it's multiplied by the A normal, and then the GL underscore position. That's our U projection matrix times the vec4, the vector position, and comma 1. Then we also have the, so that was the vertex shader. We also need a fragment shader. It's similar, except this one has more to do with the positions and the colors. So as you can see here, we have the normal light there and view there, and then we have the diffuse lighting, specular lighting. You can also use an image if you want, meaning you, similar to how you bake an image in Blender. It's the same similar thing. So you have the ambience plus the diffuse plus the specular, and if you want to put some alpha blending, because remember we want to do a glass transparency, so we just use a float alpha and we set it to 0.4, and then that's what we use in our frag color here. As I said, yeah, I learned all this stuff about 10 or so years ago, actually maybe longer, and it was really, I understood all these things. I'm actually pretty good with it because I understood it because I tried in different languages, even like the JMonkey engine. I really got really good at this. The thing that always got me was the transformation matrix. So that always got me, because I would get it. For example, something round is very easy, but a cube, because you have to, when you rotate a cube, you see the the projection changes a little bit, right? For example, if you see my hand, I've just bent my hand a little bit here. So if I rotate it like this, you see how they change. But if there's a ball, it will be, everything will stay the same. So that's why we have this. And obviously the shaders, everything, the light has to deflect off. So that's why I say WebGL 2 is not as, it's way more complex than it should be for when you're coming, especially from WebGL 1. And then you need to compile them. So this is very simple stuff to compile. So you get the shader, you get the source, and then you compile them. And sometimes there might be errors because you made a mistake. Then you have to redo it again. So this is also to say there wasn't. Some people came up with some debugging tools. So that's why I said I got really good at it. So this is just a simple function. You can find this type of stuff everywhere. And then you have to create a program as well. Yeah, yeah. As I said, WebGL 2.0. Really unnecessary complex. So then you basically just attach the shaders. So you see there's two of them. There's the whatever program we have, and the so one is the vertical shader, one is the fragment shader. Then you link them to your program. So if there's an error, you just output there's an error there. All right. So the vertex shader here, you see we call those functions, create shader, and see this one is for the vertex shader, one is for the fragment shader, and one is our program. So program basically just we'll be able to use those programs. That's it. Very see how many lines that is. Let's see. That is essentially line 16. So almost 100 lines just for that stuff. Okay, and then we have our positions here. I just use a new float 32 array, and there's a front face, there's a back face, there's a top face, there's a bottom face, there's a right face, and a left face. Because so these are faces. You know the box. You have the top, bottom, left, right, back, and front. And then they are normals, so they need to be mapped to. Normals are needed also for colors, not just. And then if you have textures, you might have specific texture ones as well. So as you can see, they just map it. This is just very simple. Think of it as points, 0, 0, like this. So for example, if I'm drawing the side, the front here will be 0, 0. Then we go here, there, and then we go this. So that's what they are. That's how they map them. And then you have the indices as well, similar to that. You see front, back, top, bottom, right, and left. Okay, and then we have the buffers. We need to create a buffer. I said this is very low level. I did a tutorial on this in the past, so you can look that up. I'm just going this a little bit quickly because I don't want to spend too much time. I said if you want me to do an updated on that, a simple one, I can do it. But essentially, you need to create. I said this is more like C programming language where you need to create a bind buffer and a buffer buffer data. That's for the position buffer. Then you need to create a norm buffer. Remember, for all the positions, we need to create the indices and all that. So you just basically make buffers. So it's very similar. The difference is actually, there's a difference. So the position buffer and the normal buffer, they're exactly the same, except obviously the data you pass into it. The indice data is different in that instead of using the array buffer, you use the element array buffer, and that's the only difference. So as usual, but you do bind them, and then you use the bind buffer, and then you use the buffer data. After that, you get the attributes. So from the program here, we enable the vertex attribute array, and the bind buffer you see here, and then the vertex attribute pointer. That should be very familiar if you're from C. I think even maybe C++. And then the norm, you do the same thing. After that, you now are uniforms. This allows us to do the rotating. See, we have the model view matrix, and then the projection matrix, and then we have the normal matrix, and then you have the light position. The light has to change as well, the bouncing off to give it that transparency, the view, and then the colors. And then after that, I create some helpers here for the matrices. As you can see here, I use the time, so you need to know a little bit of math. It's not so difficult once I said there's so many ways of doing this. So actually there's a person on YouTube, I think it's called Indigo Code. He actually spent, I think, like 1, 2, 3 years just going over every single day the WebGL. He actually even created his own JavaScript GLTF. So for example, you can export as GTF or JSON in Blender. He actually created a parser for that one as well, and I think he also created one for the binary version, GLB as well. So and then we'd have another function just for the multiply matrices. As you can see, I said this is more basic math. And then we have one to identify the matrix, and the translation matrix, and the rotation matrix. As I said before, you can get a library to do this. For example, there's 3JS, which is actually very popular for that. The reason I didn't want to use 3JS was because 3JS, every once in a while, they break the API. So if you have stuff that worked in the past, it won't work in the future. So I find that very, very annoying when I want something very simple. And then, almost done, don't worry guys, almost done here. So then we have a canvas event listener, meaning that when I put the mouse down, it's going to determine which way I'm going, left, right, or dragging. So you can see here, it saves this, and then mouse up, mouse move. So basically I can use my mouse, or if I'm on a phone, when I do the touch, it will mimic the mouse. So it will know that I want to rotate left, right, top, bottom, things like that. That's what all this does. I've also done a specific tutorial on dragging and dropping, so you can look that up. I think I made it, yeah, probably like 13 years ago or so, maybe even longer. Yeah, about 13 years ago. So that's also there. Where I created a tutorial how to create a bouncing ball, like it bounces on the side here, boom, 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 like that. So that's there. And then here we go, the render loop. This is common here on all when you're doing 3D and WebGL. So I'll just explain very simple. So to clear, you just set whatever color you want, and this one's slightly dark color. Some people just make it black, and then clear, meaning you have to clear. Remember I said this is like C programming language, so you have to clear the buffers. Then you enable the depth, and then the blend, and then you set the, see, I remember we said we have the little alpha thing going on there, and then we have a projection matrix. Here we go, I'm using the math function here, pi divided by 4, and the aspect. So this way it will give you that rotation. It's by default it's rotated slightly. You'll see that when you run it. And then we have our model view matrix. This will translate the back and then rotate, and then we have a normal one, which this is for transpose and inverse of the model view, and that's it. And then you have to run the request animation frame. So this won't work if you don't have WebGL, but as you saw in the old browser, the browser that doesn't have hardware acceleration, it does not work. I'm going to open up Chromium now and we'll run this. So here, I'll just right click on this. And so opening up in Firefox, I'm going to open up in, where's Chromium? Oh, Chromium is C. So is this? Oh yeah, Chromium web browser. Okay, so as you can see here, it's put it here for the people who are on. So here we go. You can see it's opened up. So for example, you can see now I'm rotating it. You see that? I'm using the mouse. You see it detects when I'm rotating it, and you can see there's a little. You can see the back there. You can see, I mean, the back one when I rotate. You see that? So the light is shining through. So it's glossy. So it's shining right through. It's like a glass. It's glass. So and you can see the back. So that it mimics the back there. There we go. So there we go. Rotate it. Now you can do Rubik's Cube. Good one. How do I say that? The Sherlock? I hope I said that right. Yes, it's kind of like a Rubik's Cube. There we go. So there you go. So nice. And you can see that little reflection of the light right there. I don't know if you guys caught that. Might have to. Yeah, there we go. You see the light? There, you see the light again? There we go. See up here, that's the light. Okay, so that's fun. So it's not auto rotating, and I based it on the mouse, so that way you can set it where you want. Obviously, you can set your own rotation. Now, there are other ways to do this. One simple way is you can model this in, say, something like Blender. You can also use I've done something similar using the Blender Python API. then you can export it as a GLTF or a GLB, and then you can use the model viewer, and it will show up here. You need a few tweaks, so that will work as well. But this is one where you see you can do things multiple ways. So that will be up to you to decide which one is the which one you want to actually use. Okay, I'll just leave that as well. So because I'm using the integrated graphics, I'll see if I can finish this up. So just be careful when you run this. Use a browser that has hardware acceleration. I said like the Chromium-based browsers do have it enabled. For other browsers like Firefox, they don't have it enabled. I think one of the reasons is because most of the time when you do things like this, you have to use the proprietary drivers. I'm talking about Linux, but I don't know about the others. So I think even Windows. So they probably want to get in trouble, so that's why they disable it. Now I want to show you something. So if you're in a Chromium browser like this one, they're very similar. It doesn't matter which one. So what you do is you can go to. I'll show you. Let's do the easy way. So what you do is you go to settings. Make sure I can see this properly. Under settings, we go to, I think it was system. Yeah, see under system here, you see Chromium makes it easy. So you see here, it says use graphics acceleration when available. So you can enable that, and then you have to restart your browser, then it will work. The other way to do this is if you go to, I think it's Chrome, / and I think you type GPU. I might be wrong there. Okay, I got that wrong. Chrome GPU. Is it settings? Oh, I put in I put in the wrong one. It should be up here. Chrome. It's one of these ones. I'm not sure which one it is. Is it flags? Oh yeah, flags. And then you can search for say something like WebGL. There we go. See WebGL. And then if you're running an older version, you can then enable them here, but you shouldn't need to do that. I said in the modern ones you can simply just do it that way. And you can also say hardware, and then you see here it says hardware accelerated video decode. So you see this one is enabled, and it says toggle hardware accelerated H.264 video encoding for cast streaming. So you can enable that. That'll be up to you. I like to leave the default because obviously the reason it's disabled by default is most likely it's still being tested on, or there are problems, especially on Linux. So I do not want to enable them. Now, when I was running my NVIDIA GTX 950, I was able to also do things here. I can probably enable it here as well, but I said I'm not because the iGPU is not as powerful as a dedicated one. So I said I'll wait until I install the GPU properly and then the dedicated one. But that's how you can also set it. So, but as I said, instead of doing all this trouble, it's just much better to go to the settings and do it there. So you can also here, you see there's also, I went to unavailable. You see it says WebRTC hardware video decoding. It says it's not available on your platform because I'm on Linux. And it says here WebRTC hardware video encoding. It's also not available on my system. And hardware accelerated video encode, it's also not available. So this means that if I use WebRTC to create videos in the browser, it will not have hardware. It won't have it here. I also promised to show you guys how to run this cube thing inside the on your phone. So to do that, I'm going to use, what language should I use here? I'll use PHP, but you can use any language you want. So what you do is you get the IP address of your device. So in my particular case, I think I have I think it won't matter, but I'll just type in, it's PHP space -s, capital S, space, and instead of typing localhost, I'm just going to type 0.0.0.0, and then colon, I'll put 8000. So what this will allow me to do is I can connect to this on my phone to port 8000, and I'll be able to go to this URL. So I'm going to do that right now. I should have probably used Scrappy, but that's fine. I'll do this. I'll go to, say, close all. I'm going to use Chromium browser because I know that one has hardware acceleration. So then I'll type in 192. Okay, there we go. Okay, and it's slash, what is it? Glossy, should have given it a better name. Glossy, it was hyphen, cube, hyphen, oh, it's just .html, okay, that's easy, .html. So the site cannot be reached. Oh, come on. Oh, gotta be kidding me. Let's see, 8000. Says it cannot be reached. So I think I have to actually put the IP address here, which I'm going to do in a second. I'll cancel this, and I'll put the actual IP of it. Oh, the IP probably changed. Oh, I forgot because I'm using the new system. Let's see if the IP changed here. Yeah. Oh yeah, the IP changed. It's now 106. So I can't use the other one, the old one before. Okay, so let's clear that. 106 now. So 192.168.1.106. Okay, I'm going to make sure it actually does work. .192.106. Yeah, it does work. Okay, it's 106. That's why it didn't work on the phone. Alright, so it's 106. I'm going to do it on the phone. .106. Let's see if that works. Yes, it does work. Okay, then it's slash, what is it, glossy hyphen cube .html. Here we go. Oh, where's the camera? Oh, let me unplug this. So you can see that. You see it's on the phone. Oh, it's not detecting the mouse though. Oh, I can't rotate it. Unfortunately, I can't rotate it, but you see it does work on the phone. Because I probably use touch. It's not registering the mouse. And like here, see this one, I can rotate it like this, and you can see the light as well. So you can do it also on the phone. All right, so that's the end of the programming part of this tutorial. Let's finish this up. I don't want to take this too long. I will change that video, don't worry, as soon as this screencast thing is finished. So if you enjoyed this project and want to deepen your JavaScript skills, check out my resources. I have the Learning JavaScript book. It's available on Amazon. The links are in the description. I also have the Learning JavaScript course on jamboshop.com. The link is also in the description. The course includes complements the book with hands-on lessons and coding exercises. I did lots of tutorials last year on learning JavaScript, both the book and the course. So I might start that up again if you guys want me to, but yeah, it's a lot of examples there. If you're interested in personalized help, I offer private one-on-one tutorials for JavaScript. You can reach out to me at ojambo.com/contact and to schedule your session. So some final thoughts. Building 3D graphic WebGL might seem intimidating at first, but with practice and right guidance, you can create your own interactive experiences right inside the web browser. This rotating cube is just the beginning. Keep experimenting and happy coding. Okay, feel free to leave any questions or share your own WebGL projects in the comments below. Also, quick reminder that I do a live stream every single day. What you do is you go to jumbo.com, you go to the watch menu, live sub menu. You can see this is the topic for today's tutorial, and then this one is one we're doing right tomorrow at 2 p.m. Eastern. And also be sure to subscribe, like, follow, and leave comments for more frequent content. I'd like to thank everybody who subscribed so far this month. Keep it up. It inspires me to make tutorials just like this, just for you guys. If you have any requests, let me know. I'd be glad to take a look at them, and I'll try to get them out to you as soon as possible this month as well. Okay, with that said, I'm checking the live chat and I see there's only one chat from the Sherlock. Okay, perfect. So I'll see you guys tomorrow. Have a great day.